Hi everyone, in today's challenge we are going to solve this problem. The problem name is partition list and the problem number is 86. Alright guys, so first of all what we are going to do? First of all we are going to clearly understand the problem statement. After understanding the problem statement with example, then we will move to the logic part. And in the logic part we are going to see how we can solve this problem, what is the logic, what are the algorithms we are going to use to solve this problem. So after understanding the logic part, then only we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python, C++, Java, and JavaScript programming language. Fine, guys. And guys, if you want to have a look on the solution, which I am going to write in this video for Python, C++, Java, and JavaScript programming language, I will share one link in the description. You can go through that particular link. You can find all the solution over there. Right. Now, guys, let's see what this problem says. Right. So the first step is understanding the problem statement. So what problem say? Problem says given the head of a linked list and a value x. So guys, problem says we are given one head first of all, right? Let me write head and a value x. Two things is given, right? So first we can say input is nothing but we can say list node. First is a node and second nothing but integer only, right? So we are given two things, list node and integer. Partition it's such that all node less than x come before nodes greater than or equal to x. So guys, first which was first input is nothing but not only need node list node. It is a head node of a linked list, right? Let's say head node. Let's keep it like this. It is a head node of a linked list, right? So if you link list like this, one, then two, then three, then four, so you will be having a one here, right, as input, and rest of the nodes are connected to one, right? As you know, one next is going to be two, two next is three, three next is four. This is nothing but we call a linked list, right? Fine. Now what we need to partition this linked list, right? We need to partition this linked list such that all the nodes less than x, which is this integer, all the node less than this integer should come before the nodes greater than this integer. I hope it makes sense. And you should preserve the original relative order of the node in each of two partition. What does this mean? Let's see with example. Right. So assume that we are given this linked list, right? So we have given the one node and head node. This is a head node, which we have given with head node, and we are given a x is 3, right? So integer is nothing but we can say 3. So two things we are given, right? Head node and integer, right? Now what we need to do, we need to put, right? We need to do a partition of this linked list such that all the node less than 3 should come before the nodes greater than 3 or equal to 3, right? Greater than or equal to 3. So here you can see in the example only, you can see 1 is less than 3. Yes, so it's gonna come before. They have put 1, then they have put 2, then they have put 2. So these three node, right? Let me change the color. These three node are nothing but less than or equal to 3. Not equal to, these three node are less than 3, right? So we have put these three node before the nodes which are equal to or greater than 3. You can see all the nodes right side. This is the right side. Let me change the color here. This is nothing we can say right side, right? So I hope it makes sense. So left side you can see all the nodes which are less than 3 are coming before the nodes greater than or equal to 3, right? And you can see the order as well. First we have put, because in this linked list order, first is the first node, right? Then we have a 2 as the second node, so we have put 2. Then 2 as the second node, we have put 2, right? And on the right side as well, 4 was coming earlier, right? 4 was at first, so we have put first, then 3, then 5. So order is also maintaining, right? So just we need to put all the nodes which are less than 3 before the nodes which are greater than or equal to 3, right? And let's see the second example. In the second example, we have 2 comma 1, right? So this is nothing but our linked list, 2 and 1. Our node x is nothing but what we can say 2. X is 2 means we have to put all the nodes which are less than 2 should be come before the node greater than or equal to 2, right? There's only one node which is less than 2, which is 1, right? So we have put 1 in front of 2, right? I hope it makes sense. So this is the only answer you can see in the output as well. 1 is coming before the 2 because 1 is smaller than 2 and 2 is greater than or equal to 2, right? So this is a simple problem. We are given first of all one linked list, we can say, and second we are given integer. Now we have to put all the nodes which are less than this integer front in before the nodes which are greater than or equal to this integer, right? Right. Now let's see the logic part, right? How we can solve this problem. I hope you understood the problem statement, right? Simple thing, guys. Again, I'm repeating. I've given head and I'm given integer. Now I need to put all the nodes. Let's say integer is 3. So I have to check all the nodes which are less than 3. I have to put before the nodes which are greater than or equal to 3. Right. Simple thing. And I have to return this particular linked list. Now let's see the logic part, how we can do this one, right? I hope you understood the problem, right? Problem simple, right? Now let's see the logic, how we can solve with the code. Right? So with the code, how we can do, we are going to take this simple example, first example only. We have 1, then we have 4, then we have 3, then we have 2, then we have 5, then we have 2, right? This is the basic example we do here, right? Now what we are going to do, we are going to simple say x is 3 as well, right? So now we have to do what? We have to find a node, all the nodes which are less than 3, and I have to put in the front. And all the nodes which are greater than or equal to 3, I have to put at the left, right side, or we can say last side, right? So what I can say 1. Okay, let me guess this. So see guys, this is going to be important part, right? So I have maintained a two pointer approach. Why two pointer? Let me show you. So I'm going to say this is the first part, first partition. This is the second partition, right? Fine. So initially first point and second point is partition both. I'm assuming this is the left side and this is the right side, right? So initially both are null, right? So we can say null. Fine. Now what I'm going to do, I'm going to say fine. So if you see, I am here at 1, right? Initially I'm starting at 1. 1 is less than 2 or less than 3 or greater than 3. As you can see, x is 3. So 1 is less than 3 or greater than or equal to 3. It is less than 3, right? 1 is less than 3. So we are going to put it here. First partition is nothing but 1. Then come to 4. Is 4 greater than 3? Is 4 less than 3 or greater than equal to 3? 4 is not less than 3, right? So it's going to come at the second partition. It's going to say 4 here. Then we come to 3. Is 3 less than 3? No, it is also not less than 3. So it will come to second partition. Is 2 less than 3? Yes, 2 is less than 3. So it will come to first partition. Is 5 less than 3? No, 5 is not less than 3. It will come to second partition. Is 2 less than 3? Yes, 2 is less than 3. So it will come to second partition. Now guys, you can see we have created two partition, right? First partition, it is nothing but we can say left side. And second partition, which is nothing but we can say right side. Now what simply we need to do, we need to simply take a pointer of 2 next should be pointed to the second partition of head. And you can see this is only our result. If we write 1, 2, 2, 4, 3, 5, and you can see in the output as well. Let me just little scroll up here. So you can see 1, 2, 2, 4, 3, 5. This is the only answer, right? Simple. I hope now you understood. It is an easy level problem. We need to just make two pointer, first partition, second partition. And now the thing come, you can say, okay, I got it, how it's gonna work. But actually I don't know how the logic working behind it as well, right? You got it that we are just traversing over this main list and we are checking if it is less than x, then put in first partition. If it is not less than x, put it in the second partition. And after doing this all, you have to point first partition, the last node of first partition to the next. You have to find this last node of first partition next to the second first node of the second partition, right? Simple thing. You have to find this last node of first partition. This next should be equal to the first node of the second partition, right? After doing this, you have to return the this partition only, right? 1, 2, 2, 4, 3, 5. But how we are going to do this thing, right? So let's see the complete go through this, right? Let's see the complete dummy logic here. So what I'm going to say, I'm going to say pseudocode. So like first is 1, 4, 3, 2, 5, and 2. This was our original list, right? Which we are given with. We are given head of this, right? So what I'm going to do here, I'm going to say, okay, I'm going to say my first is A, right? First partition. Let me give a name FP, which is initially what is dummy node, let's say null, right? And second partition is also initially null, right? So once I come to 1, right? What I'm going to do? I'm going to say let's create two more pointer which is pointed to these two because I need this two pointer. Why? Because I have to return the first pointer and I have to make the last node of first partition to this first node of the second partition. I have to make the last node of the first partition next to the first node of second partition, right? So I need these two pointer as well, right? So I'll keep them reserved and I will play with my another dummy node which is let's say first or second. First is pointing to the first pointer, second is pointing to the second pointer, right? So these are nothing but first partition, second partition. So they are pointing to this. So first is nothing but initially going to be is going to say if x is 3, right? So 1 is less than 3. So I'm going to say first next should be equal to this 1. 1 is nothing but head only, right? And move ahead. If it will going to move ahead. So now it has inserted 1 here. I have it making a sense, right? Now it move ahead. So first is going to be again pointed to the 1, right? Again we come move at 4. So we're going to say is 4 is less than 3, no? So second next is going to be now 4. If second next is 4 because second is pointed to second partition, right? So we can say second is pointed to this. So second point next is going to be 4 now. Fine. Let's move second to next as well. Now we add 3. Is 3 less than 3? No. Again second to next, right? Second to next is now going to be 3. So it's going to come to here. Fine. Now we're going to move ahead first. This 2. 2 is less than 3. Yes, 2 is less than 3. Now we are going to say first next should be 2. So we are going to say 2. Now come to 5. 5 is less than 3. No. Second next is going to be 5. So we are going to say 5 here. Now 2. 2 is less than 3. Yes. So 2 next is going to be, first next is going to be 2. So 2 will come here. Right. After doing this, now first is pointed to at the end, last of 2. Right. First is here, which is pointed to 2. So we can say first next. After doing all these things, first next is going to be nothing but what? Second pointer. Let me change the color. First next is going to be the starting of the this one, second partition, right? So you can say 1, 2, 2, 4, 3, and 5, right? And this we are going to make a null, right? Because now it should not point anything. 5 next should be null, right? This making null is directly we are making 5 to null, right? And you can see second partition we have some dummy node null. So we'll take care in the code part, but for now I hope you understood the logic part. What we are going to do here, we are going to simply make 2 pointer, first partition, second partition. Then we are going to make a dummy pointer with respect to them, which is going to play an important role, which is going to do the which is going to assign the nodes to the first partition or second partition. After doing all these things, once our loop will over, once we reach head to null, we are going to say first next, which always will be pointing to the last node of first partition, right? This next should be equal to the first node of second partition, right? Then we are going to return our first pointer. Let's move to the implementation part. Let's see how we can implement this one, right? So I'm with first of all with a Python. So what I'm going to do, I'm going to say fine. So let's make a first partition, which initially going to be dummy node, right? So let's give it a name, list node. And second partition, which is also going to be dummy node, right? So let's give it a name. Fine. Now what I'm going to do, I'm going to say dummy node, which is first is going to be first partition, and second is going to be nothing but second partition. And now I'm going to say file head is not equal to null, right? So while head still have some node, so we are going to say fine if head dot val is less than x. So we are going to say first next should be equal to this, first dot next should be equal to this x, this head, right? After that we are going to say first is equal to head. Else if it is not less than x, value is not less than x, so second next should be equal to this, and second is now going to be equal to head. After all these things, we are going to say head should be equal to head dot next, right? So once this is over, what we are going to do, we are going to simply say first last pointer of first partition, which is going to be nothing but first only, right? First next should be equal to starting of the second partition. So how we going to say, we can simply say second partition, right? After that we can simply return first next, not first partition next. I'm going to teach understand you what's I'm done if you are not getting this whole part. So guys, in first line what we have done, we have initialized a two node, right? Partition 1, first partition, second partition, right? After that we have defined two dummy pointer, which is going to play a role, which is going to insert node into this particular partition, right? Fine. After what we are saying, if value is less than x, if value is less than x, so it should go in first of next, so that it can go in first. So first dot next is head. So by this what we have done, we have done that first of next is going to be pointing to the head now, but we need only the first node of head, right? So we have done this, we have pointed to the first partition. Now after this what we are saying, move first to head, first should be first dot next, right? And first dot next, let me write it to first dot next, right? So this is the same thing because head is nothing but now first dot next. I hope it makes sense, right? So we can write here first dot next as well. It doesn't make sense, right? It will make same sense. All right. So here also we can write second is going to be second dot next. Fine. Let's run this code and see whether this will final work. Both way will work. If you say first is equal to head, and it will give an error. Why it is so? Just give me a second, guys. Really for sorry for this, guys. Internet is over, but I believe, guys, it will not take much time here. All right. So yeah, it's taking a time, but now it will get connected. Fine. Now let's see whether it's working fine or no. And see, guys, it will give a TLE error. Why? Let's see. No TLE. It will say cycle found. You can see found a cycle in the last node. And why is it so? Because we haven't make a second pointer to null. If you will see here, we have to make second to null. Why? Because otherwise it will keep pointing to the first node, right? So we can say second should be second dot next should be null, and we can't say null. We have to say like this. Now let's see whether it's working fine or not. Fine. I don't know why my internet is doing like this. Let's submit this code. And I hope guys it will gonna submit as well. And you can see guys it successfully got submitted. Now let's move to the next programming language, which in we can say C++. And in the C++, first of all, we are going to create two partitions. So we are going to say list node. First partition is going to be new. We can say simply new list node, right? And same list node. Second partition. So let's give the name is equal to again new node. So by this we have created two partition with the dummy node, right? Once this is done, then what we are going to do? We are going to create two more partition pointer which is pointing to this first partition, second partition. So we can say list node first, which is pointing to the first partition. List node second, which is pointing to the second partition, right? Fine. Once this is done, then we are going to use our while loop, which is going to say while head is not equal to null. We are going to say if head of value is less than x, so it should go in first partition. So we can say first next should be our head, right head, and we can say after that move one head step ahead, first of first next, right? Else we can say our this should go in second partition if it is not less than x. Second of next should be equal to our head, and second is going to be nothing but second of next. We have moved one step ahead. After doing all these things, we are going to say head should be equal to head of next now. Fine. After doing that, this value we are going to say second of next is going to be now null, make it null, and first of next should be equal to, means first of next is nothing but last node of the first partition should be pointed to the first node of second partition. So that is nothing but second partition. The first node is going to be this next because first is dummy node, right? Fine. After that, we can simply written first of next. Why we have not written first? First of node, first partition. Why we have not written only first partition? Why we have written first partition of next? Because first partition is having a dummy node, right? Its next is having our actual node. So let's see whether it's working fine or not. And we got an error. Why? Because we haven't used an arrow operation. Now let's see whether it's working fine or not. And you can see we got again an error. What is null? They don't know what is null. Either you can put a null PTR or capital N. Capital N, capital U, capital L, capital L. Alright, so it's taking a time, right? Again an error. Why next? I don't know why typo error. Let's see whether we have any more typo error or not before it's pointing. So I don't think, right? Let's see. You can see both the rest is passed. So let's try to submit this code as well. And I believe guys it will also gonna submit. And you can see guys it successfully got accepted. Now let's move to the Java. And in the Java, what we are going to do? We are going to say first of all create two node. First partition is going to be nothing but head, not head. It should be dummy node, right? List node. List node. Second partition. List node. Like this. So now what we are going to say? We are going to say list node first, which is going to do first partition, right? So which is actually going to play here. List node second, which is going to be nothing but second partition, equal to second partition right now. Now we are going to say while our head is not equal to null. So we have to keep moving, right? If head of value is less than x, this node having a value less than x, so we should go in first partition. So first of next is going to be equal to this head, and head should first should be moved now one step ahead. First of next. Fine. If it is not the case, if value is not less than equal to less than x, so it may be greater than x or equal to x, right? So it should go in second partition. So second of next should be equal to head, and second is equal to now second of next, and head should be equal to now head of next. Fine. And then what we can do? We can say second of next should be null because now we have to make it null, and we can say last node of first partition, which is the first only, right? This is the last node. And we can say its next should be equal to the first node of second partition. So first node is going to be nothing but what? Second partition of next is going to be nothing but first node, right? Because second partition itself is a dummy node, right? After doing all these things, we can say return first partition of next. Why not first partition? First partition is a dummy node. Its next is going to be our actual node, right? Let's see whether we have done any error in Java or not. So I can see a lot of error. I have a new keyword, right? It's not a Python, it's JavaScript, not JavaScript, it's Java. Fine. And you can see guys it's working fine. Let's try to submit this code. I hope it should submit as well. It should accept it, right? I want to see accepted. And you can see guys it accepted and beats 100%. Fine. Now let's move to the next programming language, nothing but JavaScript. And in JavaScript, first of all, we are going to create two nodes. So let first partition, not partition, right? And this is pointed to the dummy node, list node. Should we need to use list node, right? Then let second partition, new list node. Fine. Now we are going to create two dummy node. First dummy node. We can see dummy pointer. First is pointed to first partition. That second is pointed to the second partition. Now we are going to say while our first, not first, while head is not equal to null. Right? If it is not equal to null, then what we can say? We can say check if head of value is less than x, then should go in first partition, right? So we can say first of next should be equal to head, and first should be moved one step ahead, first of next. Or what you can do like this, or you can directly write here head, because both are the same thing, right? First next is equal to head only, right? Right. Once else we can say it should move in second partition. So second next should be equal to head, and second should be moved now one step ahead, which is equal to second dot next. And or you can like second dot next, or you can write head. Both are same thing, right? After that you can say head of next, move one step. After that while loop, once all the nodes over, all the nodes completed, so then we can say fine, now make second next is null, otherwise it will give a cycle. And after that we can say first last node of first partition should point to the first node of second partition. So last node of first partition is nothing but first only, right? This first variable, and its next should be equal to now first node of second partition, and first node is nothing but we can say second partition. Second partition dot next is nothing but the first node of second partition. After that we can list down first partition of next. ILST partition. Let's set a semicolon, and let's see whether this is the final node. All right, so let's see. And you can see both the is working, right? Now let's try to submit this code as well, and I believe guys it will also gonna submit. Let's see. And you can see guys it successfully got accepted. So we have done the implementation with Python, C++, Java, and JavaScript programming language. The only thing is here guys, if you have any kind of doubt, I know I was a bit fast in this video, but if you have any kind of doubt, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the likes, but don't forget to hit the like button and subscribe my channel. Meet you in the next video.